In this session, we're going to be continuing with our job of measuring mass, and we're going to be focusing on how to measure it, but also how to convert amounts in grams to values in both kilograms and grams. Now, opening up our textbook, we can see that our first Discover question is relating to our fairground. So I just want us to pause for a moment here, and I want you to think about what you can see in this, and decide what story this image makes. What does this picture make you think about? Is there anything that you've noticed in your own life that you can link to this? And finally, looking at this, is there any maths that you can identify straight away? So pause the video, have a little look, and think about what story this image tells, what the image makes you think about, and finally, what maths you think could be involved in this picture. Come and join me when you're ready to look at the questions we're going to be discovering today. So now let's look at the questions that we're going to be focusing on in this session. Question 1a is asking, what is the mass of a bike in kilograms and grams? And once we know that, the question is, whose guess is correct? So think about what both Richard and Bella are saying and what that means, and how we can link that to what the judge is pointing out on the weighing scales. Are there any other ways that Richard could say 3,500 grams and that Bella could say 3,400 grams? Or maybe there could be a different way that we could create the amount that the judge has already created to weigh the mass of the bike. And for question 1b, we're asked, point on the number line below to show the correct mass. So once we've worked out what the mass of the bike is, can you show me where that should go on our number line? So now it's time to pause the video and try and answer those two questions. So question 1a, what is the mass of a bike in kilograms and grams? And whose guess is correct? And for question 1b, point on the number line below to show the correct mass. So pause the video and come and join me when we're ready to look at the strategies that we've used. So let's start by looking at question 1a and working out the different strategies we could use to answer this. And let's start with the beginning part first. What is the mass of the bike in kilograms and grams? And this is where we need to take a close look at what our judge is actually doing. So we can see the bike on the left hand side of the scales, and we can see the different masses on the right hand side of the scales, something you might be familiar with in previous maths lessons or science lessons even. So now we can start counting how many masses they have placed on the right hand side. So let's begin with our kilograms, the 1 kg weights. And we can see that there's 3 of those. So simply on our number line, we've added 1, and added 1 again. And we can see there's 3 full kilograms in total, which leaves us with our grams. And again, I'm going to simply count on from 0, and I'm going to count on, in this case, in groups of 100 grams. So we can see we've got 100, 200, 300 and 400 grams. And when we use our part-whole model, we can put those two amounts together. So we can put our 3 kilograms and our 400 grams together, we've counted, to make 3 kilograms, 400 grams. So what is the mass of a bike in kilograms and grams? Well, it's 3 kilograms and 400 grams. So now we can move on to the next part of this question. And in this case, we're asking who is correct. Is it Richard who's saying 3,500 grams, or is it Bella saying 3,400 grams? Now our big problem at the moment is neither of them are correct based on what I've written. I've written 3 kilograms and 400 grams. So now what I need to do is I need to find out how I can convert my kilograms and grams into just grams on their own. So now I'm going to have to remember back to how many grams are in 1 kilogram. And in this case, we know that there's 1,000 grams in a kilogram. So instead of counting 1 kilogram, 2 kilogram, and 3 kilograms, now I'm going to start at 0 grams, and I'm going to count up in lots of 1,000 grams. So 0 kilograms, add on 1 kilogram, means I've got 1,000 grams. Add on another kilogram, another 1,000 grams, so 1,000 plus 1,000 to give me 2,000 grams, and then I'm going to add on my final kilogram, my final 1,000 grams, to give me 3,000 grams. And of course, remembering, I've already counted an additional 400 grams on top of those 3,000 grams. So now I can go back to my part whole model, and rather than adding 3 kilograms and 400 grams, I can add 3,000 grams and 400 grams to give me a total of 3,400 grams. So if you remember, Richard said, I guess 3,500 grams, and Bella said, I guess 3,400 grams, and here we can see that Bella is correct, and the total weight or total mass of our bicycle is 3,400 grams. And for question 1b, we're asked to point on the number line below to show the correct mass. So now we know the correct mass is 3,400 grams, or 3 kilograms, 400 grams. And we need to identify where that is on our number line. Now if we remember back to our very first session looking at mass, we looked at a way of finding out what the value for each interval is when they're unlabelled. And the first thing we needed to do was find the difference between two labelled intervals. And in this case we're going to look at the difference between 3 kilograms and 3 kilograms 500 grams. And the difference between that is 500 grams. Our second point then was to work out how many unmarked intervals are between those two labels. So in this case we've got 1, 2, 3, 4, 5. There's 5 intervals between 3 kilograms and 3 kilograms 500 grams, which means we're going to have to use that difference of 500 and divide it by 5. So 500 divided by 5 is going to give me 100 grams. So each interval on this number line is going to be worth 100 grams. And now we're simply going to use our number line as a real number line and count on to find where 3 kilograms and 400 grams needs to go. So we've started on 3 kilograms, 3 kilograms 100 grams, 3 kilograms 200 grams, 3 kilograms 300 grams, and finally 3 kilograms 400 grams. So on that number line we should be able to point at 3 kilograms 400 grams, which is where the red arrow shows. So now we've looked at the different strategies we can use for those. We can look at the idea of converting our kilograms and grams into grams, using that knowledge of 1 kilogram equals 1,000 grams, or we could convert grams into kilograms and grams. Know that we need 1,000 grams to equal 1 kilogram. And then we've recapped on the idea of how we can identify unlabelled intervals on a scale. So now let's carry on with the textbook and let's look at the first Think Together question. And for this we're going to be looking at the results table from some other competitions that have been carried out at a fun fair, and we need to work out the missing information. So for this we need to be thinking about our part whole models, and we're going to be separating kilograms and grams. And if we don't have kilograms, we're going to have to use that knowledge of 1,000 grams equals 1 kilogram. So we can see on part A, which has already been done, we have 1,232 grams. We have one lot of 1,000, so that becomes 1 kilogram. And we have 232 left, which tells us it's 232 grams. So what would be the answer for B? 1,567 grams. How can you separate that into kilograms and grams? Continue with those work and complete the work in the textbook before you move on to that independent activity in your workbook. And I look forward to seeing your answers and how we get on with converting from grams to kilograms and grams, or grams and kilograms to simply grams. Good luck with it, and I look forward to seeing how you get on.